Okay, so this video will be pretty short, and we're going to go over some angles that are formed by parallel lines in a transversal. So this unit we're working on we're going to see these kind of diagrams that I'm about to show you a lot, and we're really just dealing with relationships of parallel lines and then also perpendicular lines, which we talked about in class. So these are some properties that you're going to want to have memorized and just be ready to use at any point. And you'll see some of the angle properties that we've already discussed come up again in this video. Alright, so I want you to take a second and copy down the diagram. I'm going to be referring back to this diagram throughout the notes video, and so you really only have to draw it once unless you want to draw it more than once to mark the angles, the specific angles, but I'm just going to be referring to the same one. So I have my theorem written in our conditional format. So it says if lines A and M are parallel and a transversal T intersects both lines, then the following angle relationships exist. So I'm going to say some angles are congruent, some angles are supplementary. This will only be true if the two lines A and M are parallel. If they aren't, then we can't conclude that those angle relationships exist. So we have corresponding angles, and if you think about when we talked about congruence, something that came up, it was like sides that correspond or angles that correspond. So in congruent figures, corresponding sides would be the side from one figure that's congruent to the other. So and usually they're in the same place if you can get the shapes facing the right way. And so I want you to remember that as you think of corresponding angles as well. So you want to think of corresponding angles as being in the same place. So corresponding angles are in the same relative position on each line at the transversal intersection. And you want to also remember that corresponding angles are congruent. So we're looking at where the transversal crosses the two parallel lines, and we're going to have our angles be in the same spot. So we say angle 1 and angle 5. So if you look at angle 1, it's in the top left corner of the four angles formed by the intersection of the transversal. And if you look at angle 5, it's also in the top left corner. So that's what I mean by in the same relative position. And as I'm going through these, I want you to think about what are some other what are some other pairs of angles that fit these descriptions. So I've told you 1 and 5 because they're both in the top left. So if I pick angle 2, for instance, which is now in the top right, I want to find the angle that's on the top right of the intersection with the other parallel line. So think about what angle might go with angle 2. Okay, next one we're going to look at is alternate interior angles. So alternate interior angles are a pair of angles on the interior of the parallel lines and on opposite sides of the transversal. And just like corresponding angles, alternate interior angles are also congruent. So I'm going to skip to that picture again. So we said alternate interior angles, and we said angles 3 and 6. So if I look at 3 and 6, 3 and 6 are both inside of the parallel line, so they're both interior, and they are both on opposite sides of this transversal line that cuts through. So when you hear alternate, you kind of want to think opposite. Alternate sides, opposite sides, and then the interior part tells us that the angles are on the inside of the two parallel lines. So alternate interior, opposite and inside. So we also have alternate exterior, and really similar to alternate exterior angles are a pair of angles exterior to the parallel lines and on opposite sides of the transversal, and they are also congruent. So if I go to my picture, My example is angle 2 and angle 7. So angle 2 is outside of the two parallel lines, and it is on the left of, or the right of the transversal, excuse me, and then angle 7 is on the outside of the parallel lines and on the left of the transversal. So we could say that 2 and 7 are both outside of the parallel lines and they're on opposite sides of the transversal. Okay, the third one we're going to go over is same side interior angles. Same side interior angles are a pair of angles interior to the parallel line, so whether we're talking about alternate interior or same side interior, the interior part means inside of the parallel lines. And for same side interior, they're, instead of being on opposite sides, they'll be the same side of the transversal. So my example in this is angle 3 and angle 5. If I look at 3 and 5, they're both inside of the two parallel lines and they're on the same side of the transversal. So we call them same side interior. Same side interior angles are supplementary. So I actually want to go back to that picture and show you how they're supplementary. So 3 and 5. So we could say that 1 and 3 are supplementary, and that's something that we've already gone over, which is called a linear pair. 1 and 3 form this straight line right here. So I could say that 1 and 3 are supplementary. Then I've also previously said that angle 1 and angle 5 are congruent because they're corresponding. So 1 and 5 are congruent. 3 and 5 are now supplementary because 3 and 1 are supplementary. This is actually the congruent supplements theorem that we talked about, and knowing the name of the theorem isn't as important as just understanding why it ends up working out that way. So if angle 3 was supplementary to 1, that sets 3 at a certain value, and then if 5 is the same measure as 1, then 3 has to also be supplementary. So again, 3 and 5 supplementary, and there's a couple different ways I could show that. So our last angle relationship is called same side exterior angles, and you notice there's some repetition in the types of angle, or in the names of the angle relationships here. And again, we have one that's similar, but it's just changing and saying exterior. So this time the angles will be exterior to the parallel lines, but they're also going to be on the same side of the transversal and be supplementary. So that would be 2 and 8. So 2 and 8 are on the same side of the transversal, and they're both outside of the parallel lines. In the same way, I could justify why this is possible. I could say that 2 and 4 are supplementary because they are a linear pair, and then I can say that 4 and 8 are congruent because of corresponding angles. So I can conclude that 2 and 8 would have to be supplementary by the congruent supplements theorem. And something that you should notice when you're looking at this a diagram of two parallel lines in a transversal is there is really only 2 different angles that are repeated throughout because they're congruent. So those 2 angles, and sometimes I take highlighters, like I showed you guys how to highlight our angles earlier. I especially like to do it on parallel lines in a transversal because it's really easy to do. It helps you from making mistakes, and it looks like a checkerboard. So if I take one color and start with angle 1. So angle 1 right here is congruent to angle 5 by corresponding angles. And then I can also say that 1 and 4 are congruent because of, what would that be? Yeah, it's vertical angles. We've already talked about vertical angles before, formed by 2 intersecting lines in opposite angles, so I can say that 1 and 4 are congruent. I can also say that 5 and 8 are congruent because of vertical angles. And then, they're connected by being corresponding angles. So far, I already have 4 of the angles knocked off in only 1 angle measure. So then I would switch to a new color, and I could say that angle 2, just starting with 2, is congruent to 3 because of corresponding angles, vertical angles like we've learned before, so they're opposite of each other. And then I can connect 3 back to, that was 2 back to 6 by corresponding angles. So I'm going from here to here, I connected these two, and then finally I can go from 6 to 7. And if you notice, it kind of looks like a checkerboard. I don't have the same color right next to it. They're more like catty corner opposite, and that's what it would look like on a checkerboard. So even here, not the same color. I'm alternating my colors there. So that's helpful when you're doing problems with these. So what I want you to do is, on your own, identify the other pairs of angles that fit the criteria that I described, but ones that I did not list. So this is going to be especially important for the notes quiz that you did the on your own practice. Remember last time I took right from that question, and those of us that didn't do it missed out on that part for the quiz. So let's make sure we all do great on the quiz, and I will see you in class.